Hello, my name is Logan Files. I'm from Montrose High School, and for my internship, I went to a lab called USRI at Oklahoma State University for aerospace engineering. And by the way, USRI stands for Unmanned Systems Research Institute. So first is my projects. Also, I did this internship with Micah Hoffman. He presented in the earlier session. So we did this solar cell box. It's lifted to around 80,000 feet by a helium balloon. Just carries a bunch of sensors up to collect data about the sun and future energy projects. Mike and I designed the box here, and we made sure that it was insulated enough to keep all the Arduinos and electronics warm at around negative 50 degrees Celsius. We also added these angles here, so it's a more productive angle to capture the sunlight. So the next project was a telescope mount. This is for a solar eclipse happening in Australia. It's actually around a 10-pound telescope on top of a kite. And so we had to make a system that was ballast. So this is the ballast down here. And then it kind of is loose there so that it can flatten out and keep a steady image. I think there's around 6 3D printed parts on that system. So I learned a lot of SolidWorks and a lot of design. So then we got into our planes. The first plane up here is a flight test kit that was a glider. We actually decided it wasn't fun enough, so we added electronics and landing gear, and it flew very well. And then down here is our first attempt at a plane from scratch. It did not work at all. We tried working without any calculations, just kind of eyeballing it. Didn't work. That's not how flying works. So the main issue was this airfoil. It was probably too small airfoil, and then it couldn't get enough lift on the plane. So that leads into our next project, and this is a much thicker airfoil, and it's actually an inflatable wing. Dr. Jamie Jacob assigned this project, and I mainly worked on it by myself. Micah left a week early, but on this plane, it had a gyro stabilizer, which basically could keep the plane flat. So if it was flying without any controls, it would just fly perfectly horizontal at a perfect altitude. Basically fully autonomous, which is pretty cool. We couldn't have flown it without an autonomous system. It only had 2 control surfaces on the wing there, on the tail. So first we did a V-tail to try to induce roll. That didn't work out, so we went to a traditional tail. So with the tail, we could get roll and pitch. We did not get any yaw, which is not important on small RC planes, but I actually got it flying at the end. Here's it flying up there. It was pretty successful and a lot of fun. So for fun, this is the Edmund Lowe Library, and it was just nice outside at night. It was around, I think the second day we were there, it was 112 degrees and very humid. So it kind of only went out at night, but it was still a really pretty campus. And then this actually was my favorite part. This is a Pluto landing system. It's NASA's hop, skip, and jump program. Might land on Pluto in 2040. So we got to work on that. It was really extraordinary. This is on top of the Gallagher Stadium, and we just got to drop a big balloon. As Micah said, it popped, and it was pretty cool, so it was just fun. And then this is my apartment up here, or a picture of a similar apartment. I didn't get one of ours. But my advice for future Pinterns is to respect the campus, lab, your apartment, anybody helping you. Make the most of every situation and be there for the internship. It's not a travel program, and you really got to indulge into the actual internship and don't stay up all night and then be tired during the day. So, yeah, and this is the lab we worked at, USRI. So, yeah, and then just thank you to Sarah, Pinhead, Dr. Jamie Jacob, and his team, and USRI and Oklahoma State University. Thank you.